in both triangles. Fine. And last but not least, let us go back and check at B versus A2. B versus A2. I mean, if we write this as 90 minus X, for what? For triangle ABC, this B will be equals to A2, because we have said B, this B, if we write it in terms of 90 minus X, will also be equals to, in another triangle, DAC will be equals to A2, which is also equals to 90 minus X. So if we are going to write that, we are going to say B is equals to A. The reason for that it's simple, is that these sum of angles of a triangle. Now, in essence, good people, we have proven that 3 pairs or 3 angles from each triangles mentioned here are equal. So it is because of that that we can conclude by saying it means triangle ABC is also similar to triangle DAC. Fine. Then the underline, remember, we were supposed to prove this. So it means if triangle ABC is similar to triangle DBA, and triangle ABC is also similar to triangle DAC, it means the 3 triangles are actually similar. That is the conclusion. Triangle ABC is now similar to triangle DBA, and that is also similar to triangle DAC. Fine. This is what the theorem entails. That is what the theorem entails. Fine. Now I want us to move, and I want us to quickly move, because this theorem it actually introduces us to Pythagoras theorem. This is just an introduction to Pythagoras theorem. Remember, you dealt with Pythagoras every time when you came across a right-angled triangle. So Pythagoras theorem, it's a theorem that entails a right-angled triangle. Now, the conclusion that we have come up with here actually introduces us to this lovely theorem of us, Pythagoras theorem. Now, people, learners can ask, why do you say this? I want us to go back to our first conclusion. The first conclusion of first two triangles, which read as triangle ABC being similar to triangle DBA. From that, we can come up with this to say, if I look at, if I've got to look at side AB, let's look at side AB, over side DB. When triangles are similar, it means their sides are in proportion. So I'm looking at proportional sides here. Side AB must be proportional to side AB. Hence I write AB over DB must be equals to side AC of this triangle. It is the smallest side of this triangle, which is AB, over the smallest side of this side triangle DB. divided by the longer side, AC, over, is it AC? AC, I think I'm getting it wrong here. I'm getting it wrong. No, it's not supposed to be AC. It's AB over DB. This over that. That is correct. And this should have been BC, yes. This side over BA, which I can always write it as what? Which I can always write it as BA or AB. Now, if I need to cross multiply here, it means I'm going to have AB squared, which is going to be equals to BC multiply, that is this side multiplied by that side, BC multiplied by DB. That is the definition of AB squared. Fine. And this is the information that I've sourced out from where? From this similarity. I'm taking proportional sides now. Let me repeat that because I know some learners can confuse this. We are looking at AB. When you take this side, AB must be over this side. AB over DB must be equals to this side, BC over BA, which in this case I've just rearranged it as AB. I mean AB and BA are one and the same, such that when I cross multiply it gives me AB squared, which is going to be equals to BC plus BC multiplied by BD. Fine. Now let's also quickly look at this and say what happens in triangle if you still have triangle ABC. I mean, these are conclusions. This is the conclusion for the first part, and I'm now going to the conclusion for the second part. That is this conclusion. Triangle ABC is similar to triangle DAC. Now, in here, I'm going to have this. I am saying AB again. AB, that is this side, over it has to be over that side. It has to be over DA. Over DA, because these are in proportion. AB over are in proportion. This must be equals to BC over what? Over what? It has to be BC over, I've taken this one, let's go again. We have taken AB over AD, BA over AB. That is correct. Then I must take BC over AC. BC over AC. Do you have anything here? We don't have. Because I also wanted to relate AC. Maybe if I can say this is also equals to, if I take now this side, the outside side, the longest side, AC. If I can take AC over DC, I also take the longest side as DC. Now, remember I've already proved AB, so I can always leave this one behind and concentrate on this one, because now this is going to give me what? My AC squared. When I multiply this with, it's going to this is going to give me AC squared, which is going to be equals to what? Which is going to be equals to this one is going to be equals to what? It's going to be equals to CD, which is CD or DC, CD multiplied by CB. I mean this multiplied by that. So I have proved that AC squared is equals to CD multiplied by CB, when AB squared is equals to BC multiplied by GB squared. I mean, this one, I've taken it from here. Maybe others could have said, but you could have taken this one, BC over AC, and you could have taken, that is, let's start again, BC over AC, which is this one, and having forgotten about this one, BC over AC, which was supposed to be equals to AC over DC. That is still correct, because that enables us to come up with this conclusion. That I don't have a problem with that. That is still correct. Fine. Now let me take the last one, because I want to have all these sides. I want to have all these sides with me.